Hey guys, so today we're going to talk about some basic polar graphing. So when you graph a polar, okay, instead of an XY coordinate, you have what we call an R theta coordinate. So your coordinate points will look like this. Okay, R stands for radius. So remember your graph is now circular and not rectangular, so circles have radii. Okay, and then theta is an angle. Now, our simplest case would be everybody's positive. So positive R, positive angle. So what we do is let's graph a very basic point. Let's graph the point 5 pi over 3. Okay, so first of all, we're going to find the radius 5. So we're going to count out 1, 2, 3, 4, 5. Okay, once we find that radius 5, we're going to follow in the counterclockwise direction until we get to pi over 3, and then we're going to make a dot. And that's our first polar point. For reference, we're going to call that A. Okay, now let's graph another. Let's do point B, has a radius of 3 and an angle of 7 pi over 6. So again, we're going to count out 1, 2, 3, follow that circle all the way counterclockwise, 7 pi over 6. All right, now we need to talk about what happens when things go to a negative. Okay, so when R is positive, your R is measured from your positive x axis. Let's count how many times I misspelled the word horizontal. Okay. Okay, when theta is positive, we go counterclockwise. Now, most polar graphs are pre-labeled with the counterclockwise direction. You'll notice that it goes 0, then if you go up, it goes pi over 6, pi over 3, all of that. So what you might want to do, especially if you have trouble with directions, is when you get your polar graph, okay, mark it with the negatives. So that would be negative pi over 6, negative pi over 3, move this up a tad. That way, it kind of makes it a little easier. You don't have to think about it so much. But if you don't want to do that, that's fine too. Some people are really, really good at their directions, other folks are not. Just kind of depends. All right, so let's try a negative theta, okay? All right, let's say I wanted to graph the point. Let's do C is 4, negative, let's do 2 pi over 3, okay? So we count out 4, and then we go clockwise, 2 pi over 3, like that. All right, let's do another one, D. Let's go 7, negative 7 pi over 6. Okay, and you can even go like directly there if you want. 1, 2, 3, 4, 5, 6, 7, like that. You don't have to go around. So let's call that point D. All right, so when R goes negative, okay, when you have a negative radius, you actually have two different ways you can do it, okay? So it's kind of a special case. All right, so when R is negative, you have two choices. The first choice is to graph the point with a positive R, and then flip 180 or pi. Okay, so you graph your point and then you're going to flip it across the line. Okay, and then the second is to count the radius from the negative horizontal axis. And then count your angle from there. Now, since angle is rotational, your values on your polar graph can change position. Okay, so this method I think is a little bit harder unless you're really good with rotations. Okay, so let's try a couple. Okay, so point E, let's do negative 5 pi over 3. Okay, so I'm going to do the first method first. Okay, so I'm going to pretend that I'm graphing the point 5 and then negative 5 and then pi over 3. So I'm where A is. But now I'm going to flip it across 1, 2, 3, 4, 5. And that's where my E is. Okay. Well, that's it. Okay. Now, let's try another one. Or let's try the second way. So if you count 1, 2, 3, 4, 5, and then count out or rotate pi over 3 in the counterclockwise direction because that angle is still positive, guess where you still end up? Okay. Let's see if I counted my radius right. 1, 2, 3, 4, 5. Oops, I'm a little bit off. Right here. Okay. So let's try another one. Let's try point F. Negative 2, 11 pi over 6. Okay. So go 2, and then 11 pi over 6, and then flip it across the line. Okay. Now, if you start from the left, okay, you go 2, and then 11 pi over 6 in the counterclockwise direction is actually all the way around this way, and you wind up at the same spot. Most students find if you flip, that's a little easier for them. Okay, now what about the worst case scenario? What if they're both negative? Okay, so let's try both negative. Okay, so let's see. There we go. All right. Okay, so -3, negative pi over 3. So I'm going to count out +3. 1, 2, 3. I'm going to go -5 to negative pi over 3, which is right here. And then I'm going to flip it across and then wind up here. So let's call that point G. A little messy. Let's fix that. Okay. Let's go H. Let's do one more. -4. Negative, let's do 5 pi over 6. Okay, so this one I'm going to do by counting from the negative x-axis or negative horizontal. 1, 2, 3, 4. And then I'm going to go clockwise. Okay, so from 4, I'm going to go this way. So 5 pi over 6. Okay, so let's see. That would be pi over 2. And then 5 pi over 6 would be here. Okay, so that would be point H. And that's it. Okay, so that's points. Okay, now let's talk about some basic graphs. Okay. All right, the two most basic graphs you can have with a polar, okay, are your R graphs and your theta graphs. So if you have R equals just any number, you're basically graphing a circle. Okay, so if I give you R is equal to 5, then you're graphing a circle with radius 5. 1, 2, 3, 4, 5. I'm just doing a lot of circles so I can connect all my dots. Let's see if we can do this. And there we go. Okay, so that's a basic R graph. It doesn't get any harder than that. Okay, if you have a graph that says theta equals an angle, that's just going to be a line. Okay, so if I have theta equals 2 pi over 3, my graph is going to look like this. And that's it. Okay, so those are your two most basic polar graphs. Okay, I'm going to show you some more polar graphs, but we're going to use Desmos to do that. Okay.